As promised in the last video, I've implemented the state machine module of ReuseLogic Nexus. Let's have a look. Having an initial state, the brain acts as the state manager. The child state nodes contain various lists of signals for each situation: start, process, physics process, and raise and listen. The signals in the start array will be emitted when the state is initiated. As the name suggests, the process and physics process signals are constantly emitted in the process and physics process function. The raise and signal is an array of signal picker groups. The emitting of each single signal causes an array of signals to be emitted. The start delay parameter causes the state to start working after some specific time. Running the game, have a look at the state transitions. All you need to do is to add states as the direct children of the brain and name them accordingly. To decouple everything, we need a bunch of additional signals. As you see, I've separated the input signals from the actual functional signals, like walking, running, etc. We also have a bunch of signals for state initiation. The reason is that we don't want the input manager to directly emit the signals for walking, running, state initiation, etc. That's not its responsibility. It just listens to actions and emits input signals. The states are supposed to listen to input and other conditional signals and emit specific signals in return. The walk state emits any signal related to walking if the appropriate input signals are emitted by the input manager. The same applies to jump state and any other state. This way, all the logic of what is gonna happen on specific conditions is encapsulated right inside the inspector of the state node, and all the other modules get the orders directly from the state based on the signals being emitted by the active state. For example, the jump state emits the jump and fancy effect signals upon initiation, and the decoupled modules listen to these signals. The character listens to the jump signal, and the fancy effect module does its logic if the appropriate signal is emitted. So just utilizing the state machine doesn't guarantee OOP design in your project. You must be mindful about the signal interconnections between the modules and the state. But that's the subject of the ReuseLogic Nexus tutorial series, which is gonna be published when the add-on is completely implemented. For now, I'm making the brain state machine hierarchical, enabling you to add state nodes as the children of other state nodes, and do even cooler OOP tricks. Subscribe and hit the bell so you don't miss what's coming next. Thank you.